We'll continue with the problems. Now we are dealing with problems of the form. We are dealing with problems of the form integral minus infinity to infinity f of x by g of x dx or g of x by h of x. So whatever it is, numerator will be a polynomial in x, denominator will be a polynomial in x, okay? Or you can take this as g of x by h of x also, whatever it is. Function of x in the numerator, function of x in the denominator. So you have to identify it first. X square, you have x square in the numerator, then x square plus a square, x square plus b square in the denominator. So this is of type 2. So now coming to the question, you see here the limit is 0 to infinity, but in our method the limit is from minus infinity to infinity. And here looking into this function, x square, whenever it is a square, we call it as even function, okay? So here all are x square terms. So we can write this function as integral minus infinity to infinity. Some function is here, right? So this function, that is f of x by g of x. Some function, maybe h of x dx, or a function, some function into dx, and the limit is important here, minus infinity to infinity. Then we can write it as 2 times 0 to infinity, that function, okay, function into dx. So this is a property for even function. Since we have x square everywhere, x square is even function, and you can learn this property, integral minus infinity to infinity h of x dx is 2 times integral 0 to infinity h of x dx. So now from this, what will be integral 0 to infinity? Integral 0 to infinity function h of x dx is equal to, so this 2 can be taken to the other side, okay? When it goes to the other side, it comes to the new denominator, right? 1 by 2 into. So this is equal to 1 by 2 integral minus infinity to infinity h of x dx. So this is the main concept that we are using in the first step. Okay, in the first step we are using this concept, that is. So now let us use this concept here. So how to apply this? So our question is integral, our question here is integral 0 to infinity. So whenever you have 0 to infinity, we can replace it by, you see, 0 to infinity means that is equal to 1 by 2 minus infinity to infinity. So this format, okay, this you can write this step directly. You can write this step directly. Integral 0 to infinity x square by x square plus a square, x square plus b square dx is equal to 1 by 2 into the same function, x square by x square plus a square, x square plus b square dx. Okay, you can write the same function here. The first step, the same thing what I have written here, okay? 2 times 0 to infinity, this is equal to integral minus infinity to infinity this particular term dx. Or you can write this formula and you can write this step directly here, okay? So now nothing but integral 2 times 0 to infinity, 2 times 0 to infinity means minus infinity to infinity, and this 2 comes to the denominator here, 1 by 2 like. So we can, the next step we can write 1 by 2 integral minus infinity to infinity, when it, and LHS it becomes 0 to infinity. So now we have this equation. In type 2, we have this equation, integral minus infinity to infinity f of x dx is equal to integral over gamma f of z dz. This is the equation that we have to use in this method, okay? In type 2, we have to use this equation, and we know already, we learned that gamma is a closed curve. Gamma is the closed curve that is consisting of upper semicircle C. So we can correct this spelling, okay? consisting of upper semicircle C and the line minus r to r, therefore minus r to r, therefore minus infinity to infinity, and also this is a condition, you can write and minus infinity to infinity f of x dx is equal to integral over gamma f of z dz. Okay, you can make some corrections here. So this is consisting of upper semicircle C and the line from minus r to r and line from minus r to r, and this is the equation we are taking, or you can put a comma, minus infinity to infinity f of x dx integral f of x dx, okay, dx integral over gamma f of z dz. Now f of z is the question we are assuming, so let f of z equal to replace x by z square by z square plus a square, z square plus b square. Now finding the poles is the first step. We know we have to equate the denominator to 0, that is z square plus a square is equal to 0, z square plus b square is equal to 0, z square equal to minus a square, z square equal to minus b square. So from this, z square equal to root of minus a, sorry, z is equal to root of minus a square, z is equal to root of minus a square. So now the points are, if you take the square root of a square is a, but you have a negative sign, so you have to take I also. When you take square root, it is plus or minus ai. Similarly here, plus or minus bi. Okay, minus 1 means I square, root of I square is I, so we get bi. Now let us verify whether this particular point lies inside or outside. So here you see gamma is a closed curve consisting of upper semicircle and the line from minus r to r. So this is a semicircle and this is gamma. Okay, so here the curve is, in the previous method curve is a unit circle. Okay, in the previous method circle with radius 1 is the curve, f of cos theta and sin theta method, but in this method polynomial in x, you have to consider a semicircle, that is gamma, and here also the line. Okay, line, this line is minus r to r. So this point radius, here the point is minus r and here it is plus r. So we are considering this, and let us plot the points. So a comma I means here there is no real part is 0, imaginary part is the term coming with I. With I we have a, so 0 comma a. Then here minus ai means 0 comma minus a. Bi means 0 comma b. Here 0 comma minus b. So when you plot it on this curve, positive side will lie inside. You see 0 comma a, x axis 0, y axis a. So 0 comma a positive. 0 comma b. 0 comma b is also here. Okay, b is greater than a, we assume it and we plot it here. Now b minus ai means 0 minus ai. 0 minus a is in the negative side of y axis, so it will be here. 0 minus b is here. So now these 2 points lies outside the curve and these 2 lies inside the curve. So ai and bi lies inside gamma. Gamma is the curve, okay, semicircle, and negative values lies outside. So we find residue only for the inside points. So this is familiar to you. Just write down the equation for residue and you find it for ai. Okay, instead of you can replace a by ai. So here ai, here ai, f of z is the question. Okay, f of z is the first step. You can take a here. Okay, first step z tends to a. Then after that, that is a formula. Then for instead of a, you can substitute ai. Then f of z is the question. From the question we get this. Okay, here you replace x by z, that is f of z. So we have f of z here. So now you see the roots are z plus ai. When you find roots of z square plus a square, it is plus or minus ai. Here it is plus or minus bi. So this can be splitted as z plus ai, z minus ai. This can be splitted as z plus bi, z minus bi. So whenever we get roots, we will be splitting the terms, right? 2 comma 3 means z minus 2 into z minus 3. So likewise we can split the denominator. So when you split the denominator, z plus ai, z minus ai, z plus bi, z minus bi. So this minus Z minus AI, Z minus AI will be eliminated. Now you have Z plus AI, and this particular term you can write it as Z square plus B square itself. No need to split the term because we are splitting just to eliminate the term. Okay. If you want to eliminate A, you can split the A term, B term, A plus B into A minus B, no change, A square plus B square only. Now instead of Z, you substitute AI the whole square, here AI the whole square. Now solving this, A square, I square, and here 2AI, here it is A square, AI square plus B square. Okay. So now here I square is minus 1. So you get minus A square because I square is minus 1. Denominator A plus A 2I, but here you have I square, right? I square is minus 1. So minus A plus minus A square plus B square. So it will be like this, you see. Here this is AI the whole square. Z square, right? Z tends to AI. Is AI the whole square here. And when you come to this, A square into I square plus B square. Now I square is minus 1. So you get here it is minus 1 minus A square because you have a square here. I square is minus 1, A square minus A square. Then here you have I square. I square is minus A square plus B square. Now minus, here you can eliminate one of the A square and A will be eliminated. Minus A by 2I into B square. This you can interchange the term, B square minus A square. So now minus A by, you see this minus can be eliminated. Here what we do is you can eliminate one of the A, then just you interchange the term B square minus A square. But when you come to the next term, you can eliminate this minus just by interchanging this term, A square minus B square. So A by 2I into A square minus B square. Taking this minus to the denominator, it becomes A square minus B square. So this is the residue for AI. Okay, at the point AI, at the point Z equal to AI, this is the residue. Now let us find a residue at the point BI. So here instead of A we take BI. Z tends to BI, Z minus BI, then this is F of Z. So using the formula for residue, also it is a simple pole, that is pole of order 1, we get this. Okay students, we follow the same method for finding this residue also for BI. Substitute instead of Z we can substitute BI square. Denominator you can split the terms. B term you can split, Z plus BI, Z minus BI, and Z minus BI will be eliminated. And here you get, what is that? Here you can cut this F, okay, there is no F. Z minus BI by this. Then after this you can substitute I square equal to minus 1. So here minus B square will be there. Square is there, so B square, negative sign. Here also I square, B square minus B square plus A square into 2BI. So now you can cancel this B and B. So minus B by 1B will be here. Minus B by 2I into A square minus B square. So now after finding the residue for the second term, minus B by 2 and A square minus B square, we apply Cauchy residue theorem. Integral over gamma f of z dA is 2 pi I into sum of residues. 2 pi I into sum of residues, we have the residues for AI and BI. AI it is A by 2I into A square minus B square, and the other term minus B by 2I into A square minus B square. So from this we get A minus B divided by 2I into A square minus B square. Okay. So 2 pi I into A minus I. Okay, so I have written A minus I whole divided by this common term. Common term is taken here, 2I into A square minus B square. Now A square minus B square is A plus B into A minus B. So, okay, this A square, we have it here. We can split the term. After splitting the term A plus B into A minus B, after eliminating we get this as answer. So now we will go to equation number 1. Equation number 1 is You see, our question is this 1 by 2 into this integral value. Just now we got this integral value only. So we have to find the answer. We have to multiply it by 1 by 2. Our solution is